In this video, I will be discussing the scalability issues associated with the Resistive Random Access Memory, RRAM. RRAM is a type of non-volatile memory. This simply means that data will be stored even if power is not being supplied. Compared to existing non-volatile memories such as NA and D flash, RRAM is much faster and requires lower voltages to read and write data, meaning less energy is consumed. RRAM works by changing the resistive state of individual cells to either a high resistance or low resistance. Initially, the cell is in its high resistance state, with an insulating silicon oxide layer sandwiched between two metallic electrodes. A low resistance is achieved by applying a voltage pulse across an insulating silicon oxide layer, causing the formation of conductive filaments across the insulating layer. Depending on whether the cell is in its high or low resistive state, it either stores a binary on or 1 state, or binary off or 0 state. For the integration of RRAM into electronics, it needs to be able to maintain its properties and reliability when scaled up or down. The challenges that are currently being faced by researchers is that when scaled down, individual cells can only allow a small current to flow. At such small programming currents, the resistive window is smaller, meaning that it is harder to distinguish between the high resistive state and the low resistive state. This diagram shows a cycle of a RRAM cell operating optimally with distinctive high resistance characteristic in red and low resistive characteristic in blue. The green dotted line is the maximum current allowed, limited by external circuitry to prevent the circuit from being damaged. This next diagram shows a cycle of a cell at a much smaller programming current. As you can see, the characteristic of the two cycles are much more similar, and the difference in resistance between the two states is much smaller, which is represented by a smaller difference in gradient. In addition to this, the cell does not retain its electrical characteristics as well, meaning that as the cell undergoes more cycles, the position of its resistance states may change, making it impossible to read what state it is in. These issues are making it difficult to scale down RRAM cells to allow for larger clusters in a smaller space.